Alright, so we're continuing work on this Pulley problem. If you haven't watched part A, you should definitely go back. Just to recap, we drew free body diagrams for the two masses. We wrote equations of motion using Newton's second law. And we found out that we had three unknowns for our two equations. So what we needed is a kinematic relationship between the accelerations. And we started writing expressions for the length of this string here, took a few time derivatives of that expression, found out relationships of the time derivatives and the second time derivatives of these lengths or these segments of the string S1 and S2, like so. And what we needed to do is relate those back to the acceleration. Now, in my experience, I find that students have a hard time thinking about acceleration by itself. So, and a better time thinking about velocity. So let's look at velocity. I think we can get to acceleration from velocity. So I'll make the observation that I'll say velocity of block number 1. I'm just going to call this v1 in the j hat direction. Remember, j hat we already said was positive upward. So when v1 is positive, that means block 1 is moving upward. I'm not sure if it's going to move up or down right at the moment. At least my analysis isn't sure. So v1 can be either positive or negative. When v1's positive, the block is moving up. When v1's negative, it's moving down. Cool. And likewise, we'll write an expression for velocity of block 2, v2, in the j hat direction. Again, positive, negative defined the same way. So now what I'd like to do is make a connection between these components of velocity, v1 and v2, to the time derivatives of s. So let's do our little thought experiment once again, in which we say, let's suppose, for example, S1 is growing at a rate of 2 feet per second. So S1 dot is positive 2 feet per second. So if S1 dot is positive 2 feet per second, then look at S1 here. This end of S1 is fixed. This S1 moves with the pulley, or hence moves with the block. So if S1 dot is a positive, what did I say, 2 feet per second, then this pulley down here must be moving downward at a rate of 2 feet per second. So let me write this and see if it makes sense. So I'm going to say that V1 is equal to minus S1 dot V, or S1 dot in the j hat direction. How does that make sense? So again, if S1 dot is at 2 feet per second positive, then that means block 1 is moving downward at 2 feet per second. So those two have the same magnitude, right? V would be S2 2 feet per second, but they have opposite sign, because if S1 dot is positive, in other words, if S1 is growing, that means block 1 is moving downward. Downward is in the minus j hat direction. Does that make sense? In my experience, students just struggle with this to no end. So let's make a little table here. If S1 dot is positive, in other words, if S1 is growing, that means block 1 is moving downward. So this means that V1 should be negative, right? And you can go the other way around too. If S1 dot is negative, so if S1 dot's negative, that means S1 is shrinking. If S1 is shrinking, S1 dot negative, that means block 1 is moving upward, right? So V1 greater than 0. So they have opposite signs. That's why we have the minus sign there, in order to get the fact that these two things must have opposite signs. And then our expression for V2 is really the exact same story. So V2 would be related to S2 dot, right? And it'll have the opposite sign. So if S2 dot is positive, block 2 is moving down, so V would be negative. So we got to keep track of the sign in exactly the same way. So now I can make the observation, looking at these components of V1, which are the same vector V1. I can say that S1 dot is just minus V1, and S2 dot is minus V2, right? Now I can take these two relationships and substitute them into equation number star over here. Call that equation number star. So into equation star, and what do we get? It's like I got 2s1 dots, so I got minus 2v1 plus s2 dot, so minus v2 has to equal 0. So there's a relationship between my speeds, or v1 equals, I'll say it this way, v2 equals minus 2v1. So we actually see quite a bit here. So velocity 2 and velocity 1 have to have opposite signs, right? And they have to be in a 2-to-1 relationship because of the kinematics of the string. Kind of cool. But again, I'm not really looking for velocities, I'm looking for acceleration. So let me take this one step farther. So let's get some fresh screen up here and look at accelerations. The acceleration of block 1 is, I'll just call it A1 in the j hat direction as I did before. And this is just v1 dot in the j hat direction by definition. And similarly A2, it's equal to v2 dot in the j hat direction. And of course v1 and v2 are related to each other through the kinematics of the rope. So I can take, let's see if I call this equation pound sign, I'll say from pound here we get minus 2v1 dot minus v2 dot is equal to 0. I just took a derivative of that thing. So therefore I can write minus 2a1 minus a2 equals 0. So in other words, a2 equals minus 2a1. Aha, here's now a relationship for my accelerations. Now you recall our equations of motion. Remember we had 2 equations with 3 unknowns, the t, the a1, the a2. But this new expression relating the a1 and the a2 helps me eliminate one of these things. So I can take this a1 and write this as, let's see, m minus 1/2 m a2, right? Now if you look right here, I have 2 equations, one right there, all in terms of unknowns t and a2. And you can eliminate the t and then easily solve for a2. And when you do, at least here's what I get. I get a2 is equal to minus 2/5 g. And that's my final answer, I guess. One thing I should do is check the units, make sure the units make sense. In this case, it's almost trivial. A2 is an acceleration, right? So we're expecting a length per time squared. I just write out units. We're expecting a length per time squared. We look at the right-hand side. I got minus 2/5. G itself is a length per time squared. It's an acceleration. So the units check. Notice that A2 is negative. What does that mean? That means block number 2, when we release it from rest, block number 2 has a negative acceleration. So it is going to accelerate downward. So it's going to pick up speed in the downward direction. So block 2 goes down, block 1 goes up at a rate half that, right? So 1/5 of a g upward, 2/5 of the g downward for block 2. And that, I believe, ends our story.